Morning, everyone. Have you ever looked at the ground beneath your feet and wondered, how old is all this? How old is our planet? It might sound like a simple question, but for the most of human history, no one actually knew. Some thought that Earth was just a few thousand years old. Others believed it was eternal, that it always existed. Today, science gives us a very specific answer. The Earth is about 4.5 billion years old. The real story is how we discovered that number, and the story is a journey through curiosity, science, and human imagination.
Let's start from the beginning. Before modern science, people explain the world using religion and mythology. Many civilizations, from Mesopotamia to ancient China, believe God created the world recently, sometime in just few days. Even in the 17th century, famous scholar named James Ussher calculated from the Bible that the earth was created in the year 4000 before Christ, meaning it will be around 6000 years old today. For hundreds of years, that was the accepted view. But as people began exploring nature scientifically, cracks started to appear in that idea.
In the 18th and 19th century, scientists started studying rocks, mountains, and fossils. A Scottish geologist named James Hutton looked at cliffs and realized something remarkable. The layers of rock were built slowly, one over the other, over immense periods of time. He said there is no vestige of a beginning, no prospect of an end. In other words, the earth had to be much, much, much older than people thought. Later, Charles Lyell expanded on his idea in his book Principles of Geology. He introduced the principle of uniformitarianism, which means that the same natural processes we see today, like erosion, sedimentation, and volcanic activity, also shaped the earth in the past, just over millions of years instead of a few. By studying these rocks layers, geologists could tell that the earth had gone through many eras: the age of fish, the age of dinosaurs, the ice ages. Each layer told part of Earth's long but complex story. But they still didn't have a clock. They could say which events came first, but not how long ago they happened.
Then came the 19th century, the industrial age, the rise of physics and chemistry. Scientists began looking for a way to measure time inside the rocks. One idea came from Lord Kelvin, who estimated Earth's age by calculating how long it would take for a molten planet to cool down. His result was about 20 to 100 million years, which was already much older than what the Bible suggests, but still far too young compared to modern estimate. Calvin didn't know a crucial thing: radioactivity at that time no one did, and that discovery changed everything.
Now passing to the discovery of radioactivity. In 1896, Henry Becquerel and later Marie and Pierre Curie discovered that some elements like uranium naturally emit energy. They were radioactive. Later, scientists realized that these radioactive elements slowly transform into other elements over time. For example, uranium turns into lead at a very steady, predictable rate. It's like a cosmic clock. That rate is called the half-life, the time it takes for half of radioactive element to decay into other elements. So, if you find a rock containing both uranium and lead, and you measure the ratio between them, you can calculate how long that decay has been happening, and therefore how old the rock is. This method is called radiometric dating, and it completely revolutionized geology and our understanding of time.
Scientists started applying radiometric dating to the oldest rocks they could find on Earth. Some of those rocks in places like Greenland, Australia, and Canada gave ages of around 3.8 to 4 billion years, but they want to go further back, closer to the birth of the planet itself. The problem is that Earth's surface keeps changing. Volcanoes, erosion, and tectonic movement recycle old rocks into new ones. So the very first Earth that formed when the planet was young have mostly disappeared. How could we find something from that time? The answer came from the space.
Meteorites and the Moon. Meteorites are pieces of rock left over from the formation of the solar system. The same time Earth was formed, they have been floating in space untouched for billions of years. When scientists used radiometric dating on the meteorites, they found consistent age around 4.5 to 4.6 billion years. Then, after the Apollo missions in the 1960s, scientists brought back moon rocks, and they gave almost same age. This was strong evidence that the whole solar system, including Earth, formed around 4.5 billion years ago.
Today, scientists use multiple methods: uranium lead dating, potassium argon dating, and others to cross-check results. Even the oldest teeny crystal called zircons found in Australia show age of 4.4 billion years. All the evidence fits together perfectly like pieces of a puzzle, confirming that the Earth formed around 4.5 billion years ago, give or take a few million years.
So, how did we know the age of the Earth? Not through a single discovery, but through a journey that combined curiosity, observation, and science. From ancient myths to radioactive clocks, from rocks to meteorites, every step brought us closer to understand our planet's true story. Today, when we say Earth is about 4.5 billion years old, we're not just saying a number, we're expressing humanity's greatest achievement, the ability to look deep into time itself. Thank you.